Okay, we're going to talk about covalent bonding and naming today. All right, so before we go over covalent, let's review ionic naming and formulas. Are you ready? So iron with this Roman numeral, sulfide. So this Roman numeral right here is a 3, and because it's listed first in the formula, also iron, which is Fe, okay, that is a metal. So remember, the positive ion is always listed first, and the negative ion is always listed second. And since iron is a metal, we automatically know this is ionic. And then sulfide comes from sulfur. Now I need to look up the oxidation state, and that's -2. So when I look at these charges, I have +3 and I have -2, but that doesn't balance. It doesn't make 0 when you add those numbers together. So I have to find a way to make the numbers be 0. I can't just change the charges. That makes no sense. I also can't erase anything. So the only thing I can do is add stuff. So if you're stuck, remember my suggestion is add a second one of the bigger number. Don't worry about the positive or negative, just look at the actual number and add another one of the big ones. So 3 is a bigger number, so I'm going to add another one of those. So now I'm going to count how many positives I have all together. So I have +3 and +3, that gives me +6. Can I make -6 with -2s? I sure can. So I'm going to add another sulfide, that gives me -4, and another sulfide, that gives me -6. So now I have +6 and -6. Now that cancels, balance each other out, equals 0 when I add them. So now I'm going to write the formula. So I write Fe and I write S. Okay. Now I don't want to write the charges. I want to write how many I needed. How many Fe's that I need to make this ionic compound equal 0 with the charges? I needed 2 Fe's and 3 sulfides. All right, there we go. Let's look at the next one. Ammonium sulfate. So ammonium, that is NH4+. Where did I find that? Table E. Okay. Sulfate. Now this does not end in IDE, which means automatically I know I got to look at table E, right? So SO4 2 negative. All right, again, those came from what table? Table E. All right, now I need to make this balance. So I have a +1 and a -2. Those don't balance right now, okay, but this is only a +1. When one of them is a 1, you can always make it balance. You can always add more 1s to equal however many you need. So NH4 plus, add another NH4 plus. So that's a +1 and a +1, that's +2, and that's -2. There we go, it balances. So now how do I write this formula? Well, I write NH4 SO4. I can't change those subscripts, they're like stuck there, okay? They don't change. Don't change those. Don't remove them. Nothing. Okay. But now I need to look at how many I needed. Well, I only needed one SO4, so I just leave that alone. But I needed 2 NH4s. If I just write the 2 after the 4, like if I just put it right afterward, then I change that to NH42, which makes no sense. So I put something from table E in parentheses. Then I add the subscript, and there you go. Magnesium bromide. Okay, so magnesium, G, charge, oxidation state from the periodic table, 2+. Bromide from bromine, charge or oxidation state from the periodic table, -1. Right now we have 2 positives and 1 negative. Those do not balance each other out, but I have a 1, and when it's a 1, it's easy. I just keep adding more of the 1 until I get what I need. So I add another bromide, so that's -1, -2, that's +2, perfect. So when I write the formula, I write MgBr, then I look for subscripts, right? Of 1 Mg, remember I'm not looking at charges, I'm looking at how many I have. So Mg, I have 1. I don't write 1s as subscripts in formulas, but I have 2 BRs. So I put a 2 here. There we go. All right, here's a kind of question that you could be asked, okay? So what could the X be? So it won't literally be asked with these words, but same concept, okay? So how do you figure it out? Well, I use what I know to figure out what I don't know, okay? So I look up Cl on the periodic table and I find out its oxidation state is -1. And then I look here, how many chlorides do I have? Well, I have 2 of them. So I have a -1 and a -1, which gives me a total negative charge of -2. And you see there's no subscript here, right? So that means I have one of these x's. So if the total negative is -2, the total positive must be +2. So then I look up on the periodic table and see what kinds of elements could have a +2 charge. So it could be, for example, magnesium or anything else in group 2. But there are also a bunch of transition metals that have a charge of +2. Most often this is a multiple choice question and you're just going to pick the one that makes sense. Now, if you're stuck on the multiple choice question, just try all the options. Only one is going to work. All right, so now we're going to name this one. How do we name it? We look, this is a metal. When we have a metal, we name it its name. So this is calcium. And then we check the periodic table. Does it have more than one oxidation state listed? It does not, so that's it, end of it. No Roman numeral, leave it like that. Then this, well, this is 2 more elements left, which means the name had to come from where? Well, also it's in parentheses, so that's another red flag. It came from table E. So we just look it up on table E and write the name of it. So it's hydroxide. So calcium hydroxide is the name of this compound. All right, so let's look at this one, this, and this. So I have, this is iron, and iron is a metal. If you look it up on the periodic table, it has more than one oxidation state listed. So that means I need a Roman numeral. This name is oxide because it came from oxygen, okay? Now, I need to figure out what Roman numeral it is. So I do that by looking here. So I look on the periodic table, what is the charge for oxide? -2. How many oxygens are there? Well, just 1. So I have a total negative of -2. How many irons are there? Also 1. So I must have a total positive of +2. So it must be iron 2 oxide. And that's a review of Ionic. All right, so let's move on. Remembering that binary compounds are 2 different elements that are bonded together, 2, only 2. Okay, it's either a metal and a nonmetal or 2 nonmetals. That's it. When we have a covalent bond, the electrons are shared. You can see them right here. Each hydrogen had 1 electron. So they're like, you know what? You know how we could be stable if we had 2 total electrons. So like, you know what? Maybe if we shared them would be good. So this hydrogen has 2 and this hydrogen has 2 just by sharing them in between. So here's another example. So fluorine has 7 valence electrons. If we get 2 fluorines close to each other, we have 6 other electrons out here and 6 other electrons out here. It's these ones right here that are already paired up. They don't bond. And then we have 1 electron left for each of them. So what they do is share those 2 in the middle. So what ends up happening is this fluorine has 6 plus 2 is 8. And this fluorine has 6 plus 2, which is 8. So they both end up with 8 valence electrons by sharing their unpaired electrons. All right, here's another example. So here's carbon. Carbon has a Lewis dot structure that looks like this. It has 4 valence electrons. Each hydrogen has a Lewis dot structure like this with 1 valence electron. See them up here? Okay. So when they bond, they just share their pairs. So this unpaired and this unpaired form a bond. This unpaired and this unpaired form a bond, and so on. Okay, so that we end up with carbon, if we count around it, 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. It has 8 valence electrons, and each hydrogen has 2. Okay. All right, so covalent, remember, is molecular. Covalent compounds are poor conductors They are bonds between nonmetals. Don't forget hydrogen is a nonmetal, and they can be found in any state of matter. When we are naming covalent compounds, we use prefixes. You actually have to remember these prefixes, okay? Mono, di, tri, tetra, penta, hexa, hepta. Don't usually have to go past that, okay? But the rest of them you can see here. But the first 5, definitely 6, are the ones that you should focus on remembering. So again, when we name covalent compounds, we use these prefixes. You can see them all here. The first element uses just its name. So if it's a P, we say phosphorus. If it's an O, we say oxygen, okay? If it's a C, we say carbon. The second element has to end in IDE. Well, it's just like Ionic, so that's easy. And both elements are going to use a prefix, okay? So if we have 1 carbon, we use mono. If we have 2 oxygens, we say di. If we have 6 fluorines, we say hexa. Now, of course, because it couldn't always be that simple, there's one exception. Never, ever, ever use mono for the first element. So if there's one of the first element, we just say that name and we don't say mono. But if there's one of the second element, we have to say mono. It'll make more sense when you look at examples, okay? So here's the first one, CO2. So look at the first element. How many of that one do you have? Well, there's no subscript, right? So that means there's 1. But what was the exception? Don't say mono for the first one, right? And how many of the second one do we have? 2. So that prefix is di. And for the second one, we have to put the IDE at the end. So the name of this one is carbon dioxide. You already knew that, right? So remember, you don't use mono for the first element. So this should never be named monocarbon. We never say mono first. The rest of them we will say. So let's look at another example. This one, how many of the first element do we have? 2. What's that prefix? Di. How many do we have of the second one? 5. What's that prefix? Penta. And remember, the second one, we change its ending to IDE. The first one, we just say it. So this should be di, nitrogen, and we say pentoxide. We don't really write pentaoxide because that sounds awkward. So when it's oxide at the end, we leave off the A or the O in the case of if it would mono. We leave off that A from the prefix, so we just put pentoxide. All right, so let's look here. How many of the first element do we have? 1. How many of the second element do we have? 6. So when the first element has 1, no prefix. Second element has 6, that's hexa. So the name of this one, before is IDE at the end, right? Is sulfur hexafluoride. Remember, the second element ends in IDE. All right, so we look at the next one. This is water, right? But what's its covalent name? Well, how many of the first element do we have? 2, that's di. How many of the second element do we have? 1, that's mono. Remember, we use mono for the second one. So what would this be? Dihydrogen monoxide. So remember, we don't say monoxide, that's awkward. So we do use mono for the second element. All right, so for the next one, this is easy. When you have the name and you write the formula, it's easy peasy. So disulfur, what element? Sulfur. Dichloride, what element? Chlorine. How many sulfur? Di means 2. How many chlorides? Di means 2. Oh my goodness, so easy. Ready? Next one. Phosphorus, what element? P. Chloride, what element? Cl. If it just says phosphorus, how many? 1, so no subscripts. Penta is how many? 5. There we go. Diphosphorus pentachloride. First element, symbol P. Second element, symbol Cl. How many of the first element? Di is 2. How many of the second element? Penta is 5. That's it. All right. Nitrogen monoxide. Symbol of the first element, N. Symbol of the second element, O. How many of the first element? Well, 1, because it doesn't even have a prefix. How many of the second element? 1. That's it. It's just NO. That's it. Nitrogen monoxide. That's it. All done. Now you are going to practice.